My name is Austin Nelson, and I am an applications engineer at Marietta NDT. Effectively, that means that I'm the guy who helps to design and implement the programs that we put on customers' machines. Yeah, so ADR is automated defect recognition, or sometimes assisted defect recognition. And it's a way for a machine to look at an image and then find one or multiple of a list of defects that the part could potentially have. And then from there, we would identify them, mark them on the screen or whatever, and then we can quarantine good parts from bad parts so that customers know that what they're sending out is actually the stuff they want to send out. Yeah, so automated versus assisted really comes down to how much human interaction you want to have with the parts that are getting refereed. Fully automated systems, the machine makes all the decisions. It will acquire an image, review an image, and then reject bad parts and put them in a separate pile. No human ever really has to look at those images for the machine to do what it's doing. An assisted defect recognition system would acquire an image, review an image, and then mark what it believes to be what could be bad spots, at which point a human could look at either a smaller subset of images or individually marked images, so they would only focus their attention on things that are possibly bad, so that they would be able to then make the call, ultimately, is it good or is it bad? Yeah, as much as I would love to say that ADR and what I do here can be applied to any and all situations, there are some where it is better suited than others. Any case where you have a well-defined set of defects, a set of, we usually call them masters, or parts that have the defect where you can explicitly point to it, and parts where, or in situations where you're looking at many of a similar type or identical type of product, are the situations that really help ADR shine. Any situation where you have dissimilar parts, or if the delimitation between good and bad is not like a hard line, that's usually where fully automated defect recognition really falls apart, and we might have to look at something like assisted if it would even work for that situation. Assisted is really where we're kind of hitting like the bleeding edge of ADR, where you're not looking at something that is maybe well-defined. Anytime you have a fuzzy area between what is acceptable and what's rejectable is really where ADR falls apart. If you have something like dissimilar parts, ADR would kind of not be well suited to it, even though it might work in some cases. Or if you have a very qualitative analysis of the parts as opposed to quantity, where you're looking for very amorphous or tough to define defects, is not so much an ADR thing. Our software from Marietta NDT is something that we design to be integrated 100% with our systems. We write all the acquisition, we write the motion, we do all the review, so that we can marry everything together and we can fully customize an experience for the end users that's going to be the best fit. Okay, so there are some concerns with digital detectors and how the technology will kind of degrade over time. Our software, we have started implementing ASTM tests as part of some of the inspections. You can, in some cases, have maybe a penetrometer or some other indicator of the quality of the image, and we would inspect that and run a test against it prior to actually refereeing parts so that we can determine if the image is of a quality that can make a call and if there are potentially any upcoming issues with the panel that you're using. Yeah, so ADR would have a couple advantages over, let's say, a person looking at images, one of which would be speed. With a lot of the parts that have to be tested, there are several different reject criteria, maybe a dozen, maybe more, and a computer can look at those much faster than a person can. The other would be reliability. A computer will be able to look at the exact same image and give you the exact same result. Whereas if you have operators reviewing images individually, different operators might give you different results. The third would be the ability to review the things that have already been reviewed. So we can save every image that comes through and every inspection that we perform so that we have documentation of when exactly everything occurred. And it would all happen in a fraction of a second. Marietta NDT's Insight ADR. We start by talking with the end customer and whatever operators they might have, and we need to know what are you looking for specifically in your parts for defects, so that we can write something that's going to target those specific things. After that, we develop and implement an inspection routine that could involve everything from transportation of the parts into it, to acquiring the images, to quarantining bad parts. And then we work with the customer along the entire way, saying, is this okay with you? Do you want to do it this way, that way? We make suggestions. We listen to their input so that what they get is what they want. And ultimately, our goal at the end of the day is to help people move product out of their facility faster and cheaper and more reliably than they could under any other circumstance. So after an ADR system is developed and implemented at a facility, we have usually run 1,000 tests, it feels like, to make sure that everything is running properly and we are refereeing everything properly so that your good parts are good, your bad parts are bad. But it's always a little bit different once it finally gets there. We get new parts to look at. So there's a little bit of little bit of follow-up that usually happens. Some tweaking here and there, especially after the machine has ever moved. There's a little bit that goes on there. But once everything is finally in place, it depends on who the end customer is. We've had plenty of machines where the U.S. government comes in and they watch us run a couple thousand parts through a machine, and they eventually, at the end of the day, sign off on whether it is good or bad after talking to the people who supply the government, after they talk to us, and to figure out how we're doing our inspections, so that at the end of the day, everybody puts their stamp of approval on it, and we know that everybody's going to be happy. Usually, for an operator, we try to keep it pretty simple. There is startup operations. There might be some flat panel calibrations they need to learn how to do. There might be some error handling that we would walk them through on their end. But typically, it's, for the most part, we try to keep it push button, sort of, where they can just set it up, tell it to go, and hopefully it runs. If not, then we'll give them some troubleshooting to look through, and they've always got our number. Yeah, so maintenance is going to come into play on any machine that you buy. There are some that we look for looking at the X-ray source, where you have to go in and grease cables. You gotta check coolant levels on some sources. There is the flat panel detector health. There you have to check things like for dead pixels, or make an offset calibration, or redo your gain calibrations to make sure that the panel is properly responding to the energy levels from the X-ray source. And then if you have any other moving parts in the machine, a robot picking and placing parts, or if you have conveyor belts that are conveying parts in, then you want to make sure that the robot would get calibrated whenever it needs to get calibrated, that you would change out belts to make sure that the belts remain healthy, and that whatever other moving parts of this thing are properly looked after. So we've had some machines that have been running for over 10 years, where the customer has kept up on their maintenance. They'll call us if there's any major issues, and we can usually get replacement parts to them if need be. But really, it comes down to how long is your inspection going to remain relevant? If the parts change, or if the requirements for defects change, then the software is going to need to be updated. And it doesn't always mean that the physical components of the machine need to be updated, but along a long enough time span, things always wear down. I guess what you really want to drive home that it's a custom build, really. We are developing something specifically targeted to a person's needs, and so really the more information they can get us, and the more detailed their descriptions are of the things that they need, and the more images that we have, the easier it is for us to develop a system that's going to work for them in the long term.